Morning, everyone. We will get started in a couple minutes. I'm just going to wait until 9:30. Just trying to focus this handout. I want to make sure it's more clear than this. Do you guys you still hear me? Please send me a chat if you do. Okay, just 1 minute and we'll be ready. I got about 22 students already. That's very good. Just want to see why. Let's see if I can. Okay, 1 more minute and we'll be ready. Okay, I'm going to take a screenshot of who's here today. Just 1 second. And then I will start talking. Now, can you guys see my projected document clearly? I know it flickers a little. I'm trying to fix this, but I'm not sure what's happening. So I need to fix this one for next time. Okay, that's good. That's good. Okay. What I'm gonna do, guys, once I'm done with this, I'm gonna record it and I will upload it to YouTube and give you a link, you know, to the recording. So you can go back and view the lesson later. Okay. Thanks, Fatima. Thanks for replying. And as you guys know the situation, so we never planned that we were gonna move to remote learning. The kind of learning we're doing right now, it's called remote learning because we're doing it, you know, in real time, but via distance. That wasn't the plan for the college or any other colleges nationwide, but as you know, everybody is moving in this direction. You name it, you go to any college, they are all doing exactly the same thing. And luckily we managed within 1 week to prepare. I do have the experience myself because I've been teaching online, but there were so many others who don't. So we've been working with them for the past week to train them and getting ready to do something similar to that. And thank you to technology because we have technology available that would allow us to communicate with you. So please be patient, bear with me, do your very best. We're going to be very flexible with you and to get you through this. And hopefully we'll hear some good news, you know, just in the next few weeks that we were able to flatten the curve. Talking about the flattening the curve, I don't know if you guys understand what that means. What's happening is a normal curve. It's a bell-shaped curve, but what the government and scientists and everybody is trying to do to flatten the curve to make it, you know, just flatter, not go to a higher peak. So it is a normal curve that you know of, and the direction is to fight coronavirus is to do this now. Let me show you. We're afraid that it's gonna go like this. Reach a peak and then come back down. Once it reaches its maximum, you know, it has to, you know, just to slow down. So what they're fighting, you know, just to do it, just to make it like that. So that's the goal, to get a normal curve like this before it goes, you know, just out of control and goes to that peak. So that's what's happening right now. So please stay safe. If you don't have to go out, don't go out. I know it's very difficult. I've been trying to do the same for the past a few weeks. And do your very best to stay safe. And if you have to go out, guys, just follow the CDC recommendations of keeping a distance and washing your hands. This is the key. To wash hands every time you touch a solid surface, or if you go outside right away, you know, just once you get in your house, you know, wash your hands with soap for at least 20 or 30 seconds. It is a very serious matter, and we have to be very, very, very careful about it. Luckily, most people, you know, just who get it recover from it, but there are some people who are dying. So it's very serious. We never face a situation like that, and hopefully we will never face a situation like this again after it's over with. And I don't know when this is gonna be over with. I'm hoping that things will improve by mid-April or end of April. We can bring you back to the classroom, but I don't know. I personally doubt that this is gonna happen. So let's plan on finishing this course. And as I told you guys, I will support you. I'll do my very best to assist you. I'm planning on doing office hours, virtual office hours on a daily basis. And when we do office hours, I will allow you to talk and use your camera and use your microphone to talk to me if you have any questions related to what we're doing or any other questions. I will send you another schedule of my office hours for which I will be flexible. You guys tell me when do you think it's a good time, just to be available, and I will make myself available. But for now, we have the chat. We have the chat box. Feel free, just to put your comments or anything in the chat box. Probably next time I will unmute you, but this is my first time trying it, just with this large group of students. So I just want to make sure that I'll be able to control the session. That's why you are all muted. I never use Zoom. I use Zoom, just to attend meetings with other people, but I never ran Zoom, just to teach a lesson. So can you guys still hear me? Okay, just keep confirming that. If anything goes wrong, guys, please feel free to send me a text message, just in the chat room. And everybody should be able to chat, to see the chat. Thank you, Muhammad. Thank you, Amanda, Ryan, Serene, everybody who replied. As I told you guys, I will work with you. Don't worry. We're going to get you through this, and hopefully we'll get you out of this with the grade that you deserve. The exams, thank you, James. The exams are going to be online. So, but I will still provide you with a study guide, just like we did before. And I might cancel the project, the StatCrunch project, because it's going to be a lot of logistics for you to work on this one, and I know you don't need it now. So I might. It's very likely that I'll end up, just not counting the project. So you don't have to worry about the project a lot. What I like you to worry the most about is this chapter. This is the deal breaker, just for the class. If you guys, pick up the concepts of this chapter, I can assure you that you're going to do fine on the next test. You're going to do fine on the test number 4, and you're going to do fine on the final exam. That's why I'm going to take lots of time, just with this chapter, and we will be using technology. So make sure your calculator is going to be handy. We will be using this calculator. Just make sure. This is the calculator, so we're gonna need it big time in this chapter, because I'm gonna deliver this chapter based, on the use of the calculator. There is another way to deliver it without using much of the calculator, but we will be using the calculator a lot. Is this clear, guys? Excellent. All right, so let's talk about this course. And there are some nice features in this program that we are using, where I can poll you. I can do a poll here and ask you questions. You can give me feedback. So it's a nice program. And the next time, guys, you join, you just use the same link that I sent you. So I don't have to keep sending you the links. This link is good for the remaining time of the semester. Tentatively, we'll be meeting Monday and Wednesday. It's not going to be probably for 3 hours, so don't worry. I got a message from Muhammad, is asking me if I can tell you who's joining now. I can call if they're not. They should know, Muhammad. I already sent them emails. What I'm gonna do, I'm just gonna make the recording available, so they will get the recording of this. There were some students who emailed me and told me it's gonna be very difficult, for them to attend, but I hope that they will manage to do it next time. All right. Is it, what do you think, guys? Is it good so far? You think that you can handle it, you know, just this way? Okay, that's good. That's good. We'll get through it. And with technology, as long as the internet doesn't act up, I mean, I have to warn you guys, if anything goes wrong with my internet and you lose me, that means something did happen, you know, just at home with the internet, and we'll make it up. So, but I'm hoping that the internet will be stable nowadays, you know, just given that uh, everybody needs it. Yeah. Is my voice clear? Because I'm using a special microphone for this. Good. Thank you, Serene. Okay, that's good. That's good. All right. All right. Excellent. All right. Let me just prepare this. And let me tell you what's going to happen with this handout. You're going to get the recording. Not only you're going to get the recording, you're going to get a PDF file of this handout with my notes written on it. If you have a printer and you printed this one, great. If you don't, I will provide you, I will email you a PDF copy. I did already, but I'll email you one, you know, just with my notes on it. The only thing on my screen, I can still see a little bit of a flicker. I'm not sure why, but I will try, you know, just to figure this out, you know, just next time. Good. So let's get started. I'm going to try to finish section 7.1 today. It's the first section, and it is the most important section. If you pick up the concepts, it's an easy chapter, guys. I'll tell you it's extremely important, but it doesn't mean that it is hard. It is an easy chapter. We will be using technology. And once you pick it up, you know, just with one problem, you're going to be able, you know, just to do it with all the problem, because it's all the same thing every time from now till the end of the semester. And the name of this chapter, guys, is hypothesis testing. Let me give you an example of what hypothesis testing is about. Let's say someone was being tried, you know, for a crime. Well, this person will go to the court, and there will be a jury, and there will be two lawyers. One is a prosecutor, and one is a defendant lawyer. The court will have to presume that the person is not guilty to begin with. When you go to court, they have to make an assumption that the person is not guilty. So, person or defendant is not guilty. Now, who will fight for the defendant? They call it, you know, just the defense attorney or defense lawyer. That person will hire, you know, just a lawyer, you know, to defend him. But there will be another person there who is usually a lawyer, is the prosecutor. And the job of the prosecutor is to do what? Is to prove that the defendant is guilty. This is the prosecutor. Okay, now who wins? Will the defense attorney win or the prosecutor win? The person who wins is the person who collects enough evidence beyond reasonable doubt to convict or not to convict the person. So if the defense attorney managed to collect enough evidence to prove that the person is not guilty, then the jury usually will have to declare that the person is not guilty. But if the prosecutor can convince the jury and collect enough evidence beyond reasonable doubt that the person is guilty, then the jury is very likely, you know, just to decide that the defendant is guilty. The two statements that I put down there, guys, they are called hypotheses. There are two statements, and you agree with me that they're opposite of each other. So defendant is not guilty and defendant is guilty. There are two statements that are totally opposite from each other. The first statement, it's called a null hypothesis, and the second statement is called alternative hypothesis. And as I told you, the null and the alternative are two statements that are opposite of each other. For example, let me put this statement now. X equals 5. This is one statement. Can a student, just text me and tell me what would be the total opposite statement of this one? It will be X what? Not the negative. No, not negative. No, does not equal 5. Very good. Okay. Let me put something now. What about if I say X is less than 5? Can a student, text me and tell me what would be the opposite statement? More, but there is something else. I got from students greater than 5, but it's a greater or what's missing also? Greater or, who can say that? Is more or equal, exactly. Very good, guys. Okay, one more. I see the screen is paused here. Let me just, do you guys see that the screen is paused, or you see the entire screen still? Okay, let me just try to fix this. Okay, 1 second. We'll go back to the screen. It's coming. You see, technical glitches happen, so just bear with me for 1 second. If that doesn't work, I have another camera that I can use. Hold on 1 sec. Let's see if it picked it up. Just bear with me 1 second, please. That was not expected. Okay, we're back. Okay. One more, guys. If I put X is more than 5, what would be the alternative statement? Again, it's a freezing. Okay, what would be the alternative statement? Let's see what you guys saying. Less or equal to, exactly. Exactly. All right. So this is what we call hypotheses. There are always two hypotheses. Now, for example, guys, sometimes I used to drive on Ford Road and I see signs for oil change. It says, oil change guaranteed in less than 10 minutes. Somebody makes this statement right there. You see a sign, they say, we will do an oil change in less than 10 minutes. If you doubt this statement and you want to study it and verify that this is a valid statement, you have to make an alternative statement, which is the total opposite of this one. So what would be the total opposite of this statement? Let's see what people are saying here. More than or greater than 10 minutes. I agree. All right, very good. Okay, this is the first statement, and this is the second statement. Do you think, guys, an oil change business will ever do the second one? It's pausing again. No, nobody will ever advertise the second one because no one will go there when they tell you that we're going to do oil change in more than 10 minutes. So you want, just the less time, and that's why they advertise, just using the first one. But if you doubt it and you think this statement is not valid, you'll try to write an alternative statement and try to prove your alternative statement. Again, the screen is freezing. Right, guys, you see that the screen was paused, right? Yeah. Okay, plan B, guys, I'm gonna change this camera. I have another one, I'm gonna just replace it. Just bear with me for a second. See the lamp. Let's see. Just need to flip it. One second. We'll just. I'm working on it right now. This is a second camera. Okay, no, that's not working. 1 second, guys, please. Let me see what's going on here. I just need to rotate this page and I haven't been able to do that. It's backward. Once I do that, we're ready to go. One sec. So have you guys been staying home most of the time? Get in there. I'm almost done. Just 1 second. All right, I'm almost there. I'm going to share the document. I'm going to project it on my screen. Okay, let's go back. Can you guys still hear me? We're good? Okay, good, good. Okay. Okay, what I'm gonna do now, I'm gonna just go there. So, how many hypotheses every time you wanna test something that people are saying you have to make 2 hypotheses. One is called the null hypothesis and one is called the alternative hypothesis. And you have to fight for one of them. We usually fight for the alternative hypothesis. If you can collect enough evidence beyond reasonable doubt that your hypothesis works, your hypothesis would win, and then it will be approved and will make sense. If you can't, just like in the court, guys, if the jury decide that they don't have enough evidence to convict a person, then they have to acquit the person. And if they say that they have, I'll tell you why the alternative one. Nema is asking me why the alternative one. We'll talk about it in a little bit. If the jury decides that they don't have enough evidence to convict a person, then they have to acquit the person. But does that mean that the person is not guilty? No. So I think you guys, you heard of cases in the past that there are some people that we knew for sure, that they were criminals, but they have good lawyers and they manage, just to get them out of this. But if the jury decide that the person, that they have enough evidence beyond reasonable doubt to convict a person, then they can declare, just that the person is guilty. So it's all about collecting enough evidence to prove your case. Now, what does it mean for enough evidence in statistics? In statistics, it means that data sets. You get the data, you collect data, and you study your sample. And then from your sample, you can make a decision whether to support, your claim or not support your claim. It's all about making claims. As you can see now, what's going on with the FDA, guys, they're waiting for companies, to come up with a vaccination, for the coronavirus or for the treatment of the coronavirus. But the FDA cannot just approve anything. They can't just approve a medicine that hasn't gone through very rigorous studies. Now, this study is a hypothesis test. People would have to perform a hypothesis test to prove that the medicine is effective. What the FDA will be seeking in order to approve a medication, and I hope that will happen soon, is a hypothesis study that shows that the medication works as a vaccine or as a treatment for the virus. So it is all about hypothesis testing. Let me show you some other examples of why hypothesis testing is important. Let me just zoom in a little bit. Okay, here's an example. An automobile manufacturer advertised that its new hybrid car has a mean mileage of 50 miles per gallon. This is a claim. Now, how do they support their claim? They have to collect data from their cars and show that this works. It's really 50 miles. So to test this claim, a sample would be taken. If the sample mean differs a lot from the advertised mean, then you can say probably their claim, just is not valid. Let's say, guys, you study a sample of 20 cars, and each car show that the sample is about 20 or 30 miles per gallon. So this is too far away from the 50 miles per gallon. Then probably their claim is wrong. Okay. We don't know what the true value of the population mean, guys. You know that in order to know the true value of the population mean, you will have to collect, the entire population and study it. So we always make assumptions about the population mean. What we're gonna do now, we're gonna define the two hypotheses. One is called the null hypothesis and one is called the alternative hypothesis. So this is the very first step in learning about hypothesis testing. There will be 5 steps throughout, the course. Once I teach you the 5 steps and how to do them, you're done. You can perform a hypothesis test on anything. So if you have the handout, guys, this is the first definition that we're gonna do here. So statistical hypothesis is a statement or claim about a population parameter. We're gonna study the population mean to begin with. You should carefully state a pair of hypotheses, one that represents the claim and the other one is the total opposite. One hypothesis is called null. So if you have, guys, your handout, you can write a null here. And the other one is called alternative. Alternative is the total opposite of the null. Now, the null hypothesis is a statement that contains the following signs, guys. Equal, less than or equal to, greater than or equal to. So if you see a statement that has an equal sign, or a less than or equal to, or a greater than or equal to, that is a null statement. And no worry, guys, I will email you a completed one as well. Some students are asking me if I emailed this one. I did, but I will email you one with the notes on it as well. I will scan them and email them. Now, my question to you guys, if a statement has an equal sign, what would be the other statement? What sign would that be in the alternative statement against the equal? Can someone reply? Not equal, very good. So the alternative hypothesis is a statement of inequality, such that greater than, not equal, or less than. So the opposite of equal, guys, is not equal. What is the opposite of less than or equal to? What would that be? Can a student reply? So what would be the complement? Let me see. More than, without the equal sign, because it has the equal sign. So the alternative statement should not have the equal sign in there. All right. And for greater than or equal to, what would be the alternative? Remember, that has an equal sign in it, greater than or equal to. So your alternative should not have an equal sign at all. So let me see, less than, you're correct. All right. The major purpose, guys, from hypothesis testing is to choose between two competing hypotheses. One is called the null and one is called the alternative. For example, one hypothesis might claim that the wages of men and women are equal. What do you think the other hypothesis will claim? Just an alternative one to this. I'll hide this one. Let's see what we have in chat. Yes. Not equal, or men make more money than women, or women make more money than men. It has to be a total opposite of it. Okay. Your null hypothesis, guys, is have this simple. Null means zero, so it's H naught, H zero. And your alternative hypothesis has this simple, HA. And actually for a little bit of time, guys, we're gonna learn how to write and state the null and the alternative hypothesis. So here is how we begin hypothesis testing. You make two hypotheses. Let's say your claim is in HA, not in HO. But here's how we always begin. We have to assume one of them is true to begin with. So we assume that HO always is true until proven otherwise. When a person goes to court for a trial, what do they assume, guys? Can someone tell me what's the assumption that's made? We just talked about it earlier. If a person is being tried, just for a crime, what's the assumption that's made at the court? That the person what? Is not guilty, exactly. So the person is not guilty until proven otherwise. Otherwise, if you make an assumption that the person is guilty, why we're doing the trial? It's already done. And the same thing in hypothesis testing. We'll always assume that HO is true until proven otherwise. If you don't like HO, guys, then you have to collect enough evidence against it. If you like HO and you want to prove HO in your favor, you have to collect enough evidence in favor of it. But we will try, just to find HO, and I'll tell you why. So if you have a claim, you better put it in HA, because if you want to support your claim, you just put it in HA in there. So two hypotheses. We begin by making an assumption that the first hypothesis is true until proven otherwise. If we reject the first one, guys, let's say we reject HO, what can we conclude? Can someone tell me? So if HO is bad, that means HA is, who can type this? So the first one is not good. Yes, exactly. That means HA is good. But if you cannot prove that HO is bad, that means you cannot support HA. So you have, just, it's one or the other. It can't be both, guys. If I tell you, if X is less than 5, not good, that means X must be greater than or equal to 5. But you cannot have both. You cannot have a number that is less than 5 and more than 5 at the same time. So it's either the first statement or the second statement. All right. I have the entire class here. That's great. That's great. All right. Now, what we're going to do, guys, we're going to do some practice in how to state the null and the alternative hypothesis. And don't worry, enough practice to make sure that you understand how to state the two hypotheses. Okay. So I'm going to go to the second. Handout. And it seems like the screen is freezing on us again. I don't know if it is the internet or... Can you guys see this screen that I shared with you now? Okay, good, good. So let me go to this, and from there I have to figure out why the screen keeps freezing on me. So we're here, guys. Okay. We're gonna learn how to write the null and the alternative hypothesis. I'm gonna start to practice one first with you. Okay. Express the following statement using algebraic expressions, equations, or inequalities, using mu for the mean, sigma for standard deviation, and p for proportion. Then write another statement that's opposite to the original. Okay, can someone chat, you send a text message and tell us how would you write the first one? The mean ID score is less than 120. Okay, let's see what we have. Oh, I want the last one. Okay. Okay, so the mean ID score is less than 120, guys. You just write the simple mu, and let me just try again to go to the camera. I'll stop share and go back to the camera. Hopefully it is okay now. There you go. Do you guys agree with this statement? The mean is less than 120. Now, what's the opposite statement? I had students told me it's greater than or equal to 120. Now, my question to you guys, this is number one and this is number two. Is number one the alternative or the null hypothesis? Let's see what you guys say here. Remember, the null hypothesis have those signs. The null hypothesis must have HO those signs. Equal, less than or equal to, greater than or equal to. And the alternative has not equal, greater, and less. So it doesn't have an equal sign in HA. So what do you think the first statement is? Let's see. Alternative, yes. Okay, and to make sure it is alternative, you just write this. And then that must be the null hypothesis. Okay, let's go to the second one. A transportation company claims that the mean waiting time for a pickup is less than 15 minutes. Okay, can someone send a chat for this one? Yes, yes, Sharifa, you will get the recording. Okay. A transportation company claims that the mean time is less than, okay, less than, there is no equal in there, so I just write it as is less than 15 minutes. Watch, guys. And it's a mean less than 15. What would be the total opposite of this one? Mean greater than or equal to 15. So what did you learn from this, guys? Anytime you notice you put a less than, the alternative state, the other statement has to have this. These are always together. Okay, what about third one? The standard deviation of test scores is no more than 4.5. Who can interpret no more? What does it mean? Send me a text. Ryan is saying less than or equal to 2. That is correct. But it's a standard deviation, guys. So I have to write sigma less than or equal to 4.5. Can you guys tell me what's the opposite statement to this one is? I'm waiting. So what's the opposite to less than or equal to? Without the equal. If you already have a greater than, yes, I agree. Sigma is greater than 4.5. So you guys, now you know, if you ever put this one, the next one has to be this one. These are two together. These are together as well. Let's do the next one. A school administrator claimed that the proportion of students who scored 1,300 or more on the SAT is, what do you think is means, guys? 55%. Who can translate this? It's a proportion. Let me see what we have in the chat. Equal to, very good, 55%. And who can tell me the alternative statement? Not equal, excellent. Okay, now you know, guys, if you ever have an equal sign, then not equal has to follow. This is how you state the hypothesis, guys. This with that. This one with that, and equal with not equal. You cannot have any other choices. These are the three choices that you have to put all the time. Let's do one more. I'm just gonna do enough, guys, to understand this, because if you do step 1, I can take it to step 2. The mean cost of a new computer is more than 1,200. Okay, someone text me more than 1,200, how it's gonna be. And it's mean. Good, the chat has been busy. Oh, I see students are telling me that I sent a different copy. Then I'll make sure to send, just the correct one. I will send them. More than 200. Okay, I agree. And can someone tell me what would be the other statement? Remember, this is a more right here. So what's the other statement? It's going to be less than or equal to 1,200. You see the two statements. One more. The engineer hypothesized that the mean Fresnel hardness of all such ductile iron pieces is greater than 170. Okay, let me see what you guys have here. Okay, let's answer the next one, please, the engineer one. More than 170. Nama, you put less than, you agree? It's your sign is less than, so more than 170 will be this. And what would be the alternative, guys? Can someone tell me the alternative to this one, or the opposite? Less than or equal to, I agree. Okay, one more. A manufacturer claims that the thickness of the spearmint gum it produces is 7.5 100th of an inch. Let's say 7.5. We don't need to write a 100. Is, what does is mean to you guys? Remember, they're not going to tell you the sign when they give you the problem. You have to figure out, the sign. So equal or not equal, I agree. And thickness is a mean, so it's a number. So mu is 7.5, and the other one is not equal to 7.5. All right. So let's go back here, guys. and write the 3 possible statements for the null and the alternative hypothesis. Let me show you what the 3 possible statements. Let's say if I write the mean equals 5 here, what would be HA? Not equal. Very good. I hope that everybody is seeing the chat. I see it clearly. So this is one scenario, guys. Now let's say I put less than or equal here. I have to put an equal sign with the less because that's the null hypothesis. So what would be HA? So we're gonna try to summarize, guys, now. Greater than, okay, more than, I agree. And now, third scenario, guys, it's this. Mean is greater than or equal to 5. And what would that be? Less than. Very good. So you guys, when you write the null and the alternative, you either have these 2 signs or these 2 together or these 2. No other choices. It has to be one of those. I know the screen froze again. Now it's back. Good. I will try to figure out, this issue, guys, later, but we'll just try to manage for today. Okay, couple more. I thought that was it, but I got a couple more. Proportion of flights that are delayed does not exceed 15%. Okay, take 30 seconds, guys, and then tell me, text me, what would you write there? Statement and its opposite, still the same question. And it's a proportion, so you have to use the letter P. Okay, we got. Does not exceed, that's okay, less than or equal to, yeah, you begin with that, that's right. Well, I'm getting better participation than in class, guys, so I like that. Does not exceed, guys, means less than or equal to 15%. And the alternative statement will be more than 15%. Remember, 1 and its opposite, always, you have to do that. Okay, one more. We claim that the mean nightly hotel price for hotel in South Carolina is no more than 65. Since it's a mean, guys, you just put a mean, and then we're gonna put the 2 statements. Less than or equal, okay. Let's see what you're gonna, guys, give me for the last one. Oh, does not exceed, Muhammad, does not exceed means less than or equal to. That means you cannot go above 15%, so it's 15% or less. 15% or less, Muhammad, means less than or equal to. The opposite to less than or equal to is greater than. Yeah, I know. Fatima is telling me that the camera froze. Let's share the screen for now. So we're here, guys. We claim that the mean nightly hotel price for hotel in South Carolina is no more than 65. So I'm sharing with you the screen right now. So let me see. write down the statement and then its opposite. You don't have to tell me which one is the null and which one is the alternative because it's going to be in the second practice. Okay, let me stop share and try to go to the camera. All right, let's go back. So let me see what you guys put in there. Less than or equal to 65, I agree. And then more than 65. Very good. Okay, here's the next thing. Now we're gonna do the same exercise, but you guys, you have to label which one is HO and which one is HA. Remember, HO must have one of those signs. And HA must have one of those signs. So we're not gonna mix them up. In the book, he states HO first, which is the null hypothesis, and then HA, and we're gonna follow the same practice. So you guys have the first question. A school publicizes that the proportion of students who are involved in one or more extracurricular activity is 61%. Take 30 seconds and then text me and tell me what's HO first and what's HA. Don't go away. Okay, let me see if I can focus this a little bit more. Yeah, I'm aware of this. Usually it's crystal clear, and I'm not sure what's happening. I'm thinking thousands and thousands and probably millions of people are using Zoom today. That's why there is a lot of traffic in the server. I tested it, just with other people for hours, and it was perfect. And today is acting up, so we have alternative, guys. So no worry, we'll try to fix this. I can zoom in a little bit more. What about now, guys? Is it better? That's good. Yeah, just bear with me, guys. There are going to be glitches. I cannot promise you it's going to be very smooth, but we will overcome the challenges. As long as you guys stay safe and healthy, that's the important part to us. So we will manage. And the nice thing that we have time, I can record the stuff and send it to you. So we don't have to stick, just to what we used to do. So we have a lot of flexibility, just to get things done. All right, let's see, guys. What do you have? Someone hit that chat and tell me what you have here. So what's an HO and what's an HA? HO is called H0, null hypothesis. Okay, somebody, Ryan, says equal or not equal. I agree. And here's how you write it down, guys. This is a 20% of your grade on the next test if you learn how to write the null and the alternative hypothesis, because there are 5 steps. I usually give 5 points for the problem and 1 point for each step. You're gonna earn the first point today by learning how to state the null and the alternative hypothesis. So P, you have to write P because it's a proportion. You cannot write mean, mu, equal 61% and not equal 61%. Do you guys agree with this statement? If any questions, please text me. Okay. Now my question to you, where is the claim? Is the claim in HO or HA? Read the question and see where the claim ends up being. The school publicizes that the proportion of students is 61%. Oh, okay, I got from 2-3 people, they're saying it's an HO, and I agree. So look what you do, guys. You write that the claim is here. This is the first step. You cannot decide on the claim yourself. It's what the problem tells you. What is it in the question? Not what you think yourself. It's what they say. So this is where the claim. Okay, let's go to the next question. A car dealership announces that the mean time for an oil change is less than 15 minutes. Okay, guys, on a piece of paper, write down the null and the alternative, take a little bit of time, and then we'll do it together. And make sure to label where the claim is as well. So write HO, write HA, and then tell me where the claim is. All right. Okay, let's see what we have here. So less than. Okay, less than would end up in where? It's going to end up here, because we know the alternative must have the less than. Even if he says less than, it can be in the alternative. You don't have to start writing your HO first. So what would be the null hypothesis? Less than, okay, and more than or equal to, I agree. And you guys, you can put minutes here. Minutes. And the claim is in HA. Which is good, because as I said, and we'll explain why later, that you always try to put your claim in HA. Okay, next one. Census Bureau data shows that the mean household income in the area served by a shopping mall is 72,500 per year. A market research firm questions 100 shoppers at the mall to find out whether the mean household income of mall shoppers is higher than that of the general population. And you see, guys, I boldface higher. So we want to test the claim if the mean is higher than that of the general population. Can you take a few seconds and write down HO and HA for me? It's about the mean again. Ryan, higher doesn't have an equal sign. Higher means more. And Sharifa, you say less. Oh, okay, this is for the previous one, probably. Greater than, yes. Isra is saying greater than for HA. That should be an HA because that's dedicated for HA. Okay, so greater than, And greater than what? The national average is 72,500. And that's the claim, guys. So you see, we end up writing the alternative before we write the null, which is okay. This is how it works. If the claim is in the alternative, we write the alternative first. And less than or equal to, I agree. Yeah, Nama says less than or equal to here. Yes. And your claim happened to be in HJ. So you guys, you don't have to start with HO all the time. It depends what the statement given to you. You write the first statement, but make sure if your statement is a greater than, you have to put it in HA. You cannot put it in HO. Okay, let's see number 4. Last year, your company's service technicians took an average of 1.8 hours to respond to trouble calls from business customers who had purchased service contract. Do this year's data show different average response time? The average is 1.8. They're asking if the average is different. So now you need to interpret this. That shouldn't be too hard, guys. It's average, so mean. And you notice I'm putting a column there. You have to put a column when you write, the null and the alternative hypothesis. I forgot to mention that. So you put HO column, and then you put mean or proportion, and same thing here, and then you write the statements. So let's see what we have here. Yes. So Fatima Al-Zaghir saying equal or not equal. I agree, Fatima. Different means not equal. So what was it? 1.8. And Fatima, where is the claim? In HO or HA? We're doing chapter 7, 7.1. It's in HA. No, it says, do this year's data show a different average? Different means HA. Equal means HO, so it is in HA. Okay, one more. Number 5. A manufacturer of tires claims that less than 3% of their tires are defective. First of all, guys, tell me which one you're going to choose, mean, proportion, or standard deviation. It's a percent. So can someone text us, everybody, and tell us, is it a mean or a proportion or a standard deviation? Proportion. Yes, because it's a percentage. It can't be a mean. I agree. It is a portion. That's correct, Isra. Okay, so write it down, guys. HO, HA. I'll wait about 15 seconds and then we'll get, send me some text, what you think should be there. So it is a proportion. I can do that. I can put a P and P there. We still have a few more. I'm gonna make sure that you guys grasp this very well because it's extremely important. If you don't write the first statement correctly, you're not gonna be able to perform the test, the hypothesis test. Okay, let's see what we have here. That is correct. Michaela, yeah, less than or equal to 3%. So less than 3% should be here. But what is the opposite of less? Let me see what students put. Greater than or equal to, yes. So people who says less than or equal to, that's not correct because the less is in the alternative. What's the opposite of less? Greater than or equal to 3%. And where is the claim, guys? The claim is in HA. I know some of you are confused with those signs. So make sure if you have any questions about the signs to contact me. I'll make sure that you understand them well because that's very important. When the sign contains the letter, that means it's a greater than. And when it is away from the letter, that is less than. You see, here the sign contains the letter. You see the P is inside. So that's a greater than or equal to. Yeah, that is correct. Asma. Okay, one more. A senator running for office again claims that he has a majority of voters. Let's see how many of you can do this. What's majority? Can someone explain to me what you mean by majority? Let's see. I got the text here. Greater than what? If you have majority of votes, what means? It means you have a greater than what number? Half, exactly. Fatima, yeah. So it's a proportion. It's more than 50%. So it's a proportion, guys. P and P. And it's more than 50% or half. I heard some students put half, you can do that. But since a percent, I'm just going to use a percent. And this one will be less than or equal to 50%. Okay. Good. Yeah, I agree. I agree, Jihan. Yeah, less than or equal to. Next one, 7. Standard deviation of waiting time at a restaurant is 12 minutes. Now it's about time to use the standard deviation sign. Okay, let's see what we have here. Michaela says equal and not equal, and I agree. And where is the claim, Michaela? Is it in HO or HA? Yep. I agree. I hope that everybody has been able to open the chat box, guys. So it's 12 and not equal to 12. And here is the claim. Okay. Any questions, guys? Here's what I'm gonna do today. I'm gonna send you a handout just on how to write the null and the alternative hypothesis. And I'm gonna make myself available tomorrow at 10 o'clock if people wanna, just come online live with video and audio, just and chat, just about the questions. So I will make, as I told you, I'm gonna make myself available almost every day. I'm gonna try to fix the time so that you guys don't get confused. It's the same time. Then just that you can come in. So I'm gonna send you a link to some virtual office hours sessions, and I'll send you a handout. You work on it. Every time we do something, I will send you a handout, so you can practice and just make sure you understand what you're doing, and then you can come back to me and tell me if you have any questions. I can go over them. It could be 10 of you in that virtual classroom or 5 or 1, it doesn't matter, but I will make myself available. So I'll send you information. Any questions, guys, about how to state the null and the alternative hypotheses? Yeah, I will send this handout, Muhammad. I thought that I did send the exact one, but it seems probably I didn't. So I'll send you this one for sure. And I will PDF this one once we're done, and you can get a complete version as well. So I will provide you with a guided notebook for every single chapter. So no worry, guys. You can count on that. You can use it. Okay. Let me tell you what we're gonna do next. And okay. I want you to just listen carefully. So we finished with step one. Step one is state the null and the alternative hypothesis. We're still gonna do more problems, but this is step one. I told you there are 5 steps, but let me show you this scenario here. Okay. I want to go back to the court case because that's a very important example. When the jury makes a decision, defendant is not guilty or defendant is guilty, do you think that there is a chance that they made a mistake? Can you reply to this one? There's always a chance of them. Can they be 100% sure, guys? Never. Good, good. They can never be sure. They just follow the evidence. As I told you, if you know a person is guilty for sure, and a good lawyer was able, to put together some kind of scientific, good, logical evidence, they have to accept him. So there is a chance of making a mistake. Have you guys heard of cases that some people were put in jail 20 or 30 years, just ago, and with the advancement of technology and DNA technology, they discovered that those people were innocent and they did not commit the crime? Have you heard of cases like that? Okay. So that means the mistakes, just were possible. So you guys, would you agree with me that a jury would declare the defendant is not guilty, but in fact, probably the defendant is guilty? Could that happen? Good. And is it possible that the jury will declare that the defendant is guilty, but in fact, the defendant was not guilty? Could that happen? Okay, these are mistakes. These are errors, and I'm going to define those errors. Now, which error? Okay, let me tell you what a type 1 error first is. There are 2 types of errors in statistics, and statisticians try to minimize those errors. The first one, type 1 error, is when you reject HO when it is in fact. Can someone tell me what's the word? You're rejecting something that is, let's see what you guys, that is true. I agree. So someone is telling me 2 + 2 = 4, and I'm telling them it's false. That is an error. You are rejecting something that is true. That's a type 1 error. Let me tell you what a type 2 error. When you fail to reject HO when it is in fact, you fail to reject, you're supposed to reject things that are false. Like 2 + 2 = 5, that's false. I'm supposed to reject it. But if I don't reject the statement and say, yeah, it is okay, that is a type 2 error. So when you fail to reject HO when it is in fact false. These are the two types of errors, guys, that you need to understand. Let me tell you, and now you're going to tell me which one is a more serious error. I'm going to go to the court case. The defendant is not guilty, and you guys, so this is a true statement, and you decided to reject this statement. Is this a mistake? What do you guys think? It is a mistake. And this is a very serious mistake. You know why? Because you're putting an innocent person in what? You're sending an innocent person to jail. So this is a very serious mistake if you make a type 1 error in the court case. Let me tell you what a type 2 error in the court case means. The defendant is guilty. We know for sure that the defendant is guilty, but you could not collect enough evidence to convict the person, so you acquit the person. This is called a type 2 error. It means that you're putting, just a guilty person on the streets again. Now, which mistake would you be able, guys, to live with and you wouldn't lose your sleep over it if you were the person to make a decision? Putting an innocent person in jail, or putting a convicted, just a convict, just back on the streets? I know what the answer is for me. Let me see what you guys think. So would you be more comfortable putting an innocent person in jail, or you have to make one of those mistakes, or a convicted person back on the streets? Let's see what students are saying. Yeah, I agree. Convict back on streets, I agree. You don't want to put an innocent person in jail. So this is the fact of life, guys. Mistakes can happen in statistics, and you gotta be able to minimize those mistakes. We try to minimize type 1 error, we try to minimize type 2 error, but the problem is when you try to minimize one, the other one goes up and vice versa. So you have to find a balance. You don't have to worry too much about it, but you just need to understand, guys, that there are mistakes can happen in statistics. You can never be 100%. The only case, guys, when you can be 100% is when you survey the entire population, and that's not possible. Even the census right now, guys, I don't know if we're going to be able to complete it this year, given what's happening right now. Yeah, see, I got the responses from you guys that you think you can live with putting a guilty one out rather than putting an innocent person in jail. I agree 100%, because that's definitely, that would be a decision that I wouldn't feel bad about it if I have to choose between one or the other. So we're gonna define type 1 error right here. I'm gonna write it down. Seems like the camera now it's working. Okay. A type 1 error, guys, occurs when you reject HO when it is in fact true. I wrote this down already, but I'm gonna write it again. And a type 2 error occurs when you fail to reject HO when it is false. Okay, now I need your help on this, guys. We're gonna fill out this table. If HO is true, let's assume HO is true, and you don't reject it, did you make a correct decision or not a correct decision? Tell me. So HO is true, and we don't reject it. Remember, guys, you're not supposed to reject something that is true. You're supposed to accept it. So if you don't reject it, that means you accept it. Is this good or bad? Let's hear. Good, good. Yeah, I hear good. Yeah, so correct decision. Now, let's go to this. HO is true, but you rejected. What do you say here? Where my fingers are pointing to now. So HO is true, but you end up rejecting it. So you reject a type 1 error. Very good. They write I for type 1, just like in Roman letters. Okay, let's go to the next one, guys. HO is false, but you don't reject it. So you didn't reject something that is false, guys. Somebody is giving you a false statement and you accept it. What type of mistake? It is a mistake? Yes, it is a mistake. Type 2 error, yes. Okay, next. HO is false, HO is bad, and you end up rejecting something that's bad. I think that's good. You're doing the right thing. So what would you write here, guys? Correct. I agree. Correct decision. All right. Any questions, guys, about type 1 error and type 2 error? So you need to understand, those two, that mistakes do happen in statistics, where statisticians try to minimize those mistakes, but there is always a chance that a mistake does happen. And I'm going to show you how a mistake can happen here and talk about the consequences of it. So let's do example 2, this example, guys. And as soon as we're done, I will email you the correct version of this handout. So let me read this question for you guys. I'm gonna do a screen share with you so you can see it. All right, we're here. Okay. So I'm right here, example, the USDA limit for salmonella contamination for chicken is 20%. So there's a limit, 20%. A meat inspector reports that the chicken produced by a company exceeds the USDA limit. So somebody is saying, a meat inspector checked this place and they say their contamination limit is more than the 20%. Exceeds means more, guys. You perform a hypothesis test to determine whether the meat inspector's claim is true. It's a very serious claim. If this claim is true, this business, that place can go out of business. So you have to study the claim. You have to have proof that your claim is true. Here's what I want you to do in this one. I want you to write the null and the alternative hypotheses, and then we will discuss together what does it mean to have a type 1 error here, and what does it mean in this situation to have a type 2. So I'm going to give you a minute, guys, to state HO and HA first. Remember, the claim is exceeds the contamination, the amount of contamination exceeds the limit. What's the limit? 20%. So write it down and then we'll discuss that. Then I'll go back to my handout, show you from here. I'll stop sharing here. And I'm back here. So let's see, I have a text here. Yeah, greater than 20%. So it's a proportion since he used a percent. So let me write it down, guys. The inspector is saying it's more than 20%. And you know the opposite of more, guys, is less than or equal to 20%. All right. What would be type 1 error here? By definition, type 1 error when you reject HO when it is actually true. What kind of damage does this do to the business? So state type 1 error, you reject HO when it is actually true. What's your interpretation of this? What does it mean for the business? Does it mean that the business is fine, the contamination level is okay, but the inspector, just said otherwise? Would you agree with this statement? So can someone send me a statement, just what do you think the interpretation of this? So type 1 error means you reject HO when it is actually true. So that means the contamination level is actually less than or equal to 20%, but the inspector, just meat inspector decided otherwise. He will be harming the business this way, but the business was doing just fine. That's what it means. So I'm gonna write it down. State the type 1 error. Actually, the contamination level was less than or equal was indeed less than 20%, but the inspector decided otherwise. Do you guys think that this will cause a loss to the business? Let me see what people are saying. Okay, what kind of loss? What does it mean for the business? They're gonna take, their products off the shelf, although they're okay, but then it's because the inspector said otherwise. So this is a big loss, just to the business. But let's look at type 2 error, guys. Type 2 error, by definition, fail to reject HO when it is false. That means contamination level is more than 20%, but you fail to acknowledge that. So contamination level, when you fail to reject HO when it is false. If HO is false, that means HA is true. If the first one, guys, is false, that means HA is true. And HA says contamination is more than 20%. So that means the contamination is more than 20%, but the inspector failed to acknowledge that. Is this bad? Okay. Ryan is saying that type 2 error is more serious. Can you explain why? I agree with you. I'm gonna write type 2, you're right. Because people can get sick. I agree. Because the inspector failed to say that this one is the meat is contaminated, and you keep it on the shelf and people buy it and they get sick. People could get, I agree, sick as a result of consuming this meat. So you guys, sometimes type 2 error is more serious, sometimes type 1 error is more serious. In the court case, guys, type 1 error was more serious, and here it's type 2. It depends it depends on the situation. So good. Yeah, I do agree with what you said. Okay. A few more things and we will be done. And as I told you guys, I'm going to make some office hours, virtual office hours available. And I promise I'll try, just to work out the glitches with the technology that I'm seeing today, see what's happening with the cameras. All right. So we're going to do, it's a little bit, just more definitions. So there's a couple more definitions that I have to show you. And then I'm going to show you a video and how we're going to proceed. We're still working with step 1, guys. That's learning how to state the null and the alternative hypothesis. Okay. We say, guys, we can make a type 1 error. You cannot avoid it. There is no way that you can be 100% sure. But we say, statisticians try to minimize this error. So what is a level of significance? Level of significance is they tell us what's our maximum allowable probability of making a type 1 error. So they can tell me, you can go with type 1 error up to 5%. So you can go up to 5% or 10% or 1%. This is your maximum allowable probability of making a type 1 error. This is called the level of significance, and they call it alpha in statistics. And it's written like that, guys. Alpha. So this is your maximum allowable probability of making a type 1 error. It is denoted by alpha, the lowercase Greek letter alpha. By setting the level of significance at a small value, you are saying that you want the probability of rejecting the null hypothesis when it is true to be very small. I'm going to show you in statistics, guys, that these are the commonly used levels of significance: 10%, 5%, and 1%. In medical fields, they require alpha to be 1%. That means they want to minimize the probability of making a type 1 error. And now they're working on vaccine, just for coronavirus. I can bet you that the FDA will require, just alpha to be 1% for all the studies that they're gonna process later. I'm hoping that there will be something, just there soon, but the study has to be a 1%. So the maximum allowable probability of making type 1 error is 1%. What does it mean? We cannot make it 0%. That's impossible. It means that they have to use large samples. The larger the sample, the smaller the chance of making a type 1 error. The only way, just for a type 1 error to disappear if you survey the entire population. And as they're studying patients with coronavirus now, when they do studies, guys, do you think they're going to do it on every single patient? We don't even know how many are infected, so that's not possible. And that's why they have to choose alpha. And the common alpha in most statistical study is 5%, but I can tell you guys, for medical research, it's usually 1%. That's the value of alpha. Now, I'm going to end this lesson with a video, and let me tell you how we're going to proceed, just next time. So you state the null and the alternative hypothesis. This is the first step. The second step is they will give us a sample. And they will give us, a summary, just of the data from the sample, like the sample mean, the standard deviation, the sample size. We will use the sample data just like we did in chapter 6, guys, when we did confidence interval. They'll give us X bar or P hat, etc. So we will use, just the data provided to us to convert, just what's given to us to a test statistic Z or T. As you remember, guys, from the confidence interval chapter, we did Z and T. And then after that, we find a number called the p-value, which I'm gonna run a video and to show you, just what the p-value is. Our goal when we do a hypothesis test is to make one of two decisions. So this is This is it from now till the end of the semester. Your goal is to answer one question, and the question is, do I reject HO, the null hypothesis, or fail to reject HO? We're going to learn what to do in order to reject HO or fail to reject HO. Why this is important, guys? If I take you back to this one, if I can reject HO, if I can show you guys some techniques, just to decide whether you can reject HO or not. If I reject HO, that means HO is bad. What does it mean for HA? Can someone tell me? If this is bad, let me see what in the chat. Okay, Ryan is saying that means HA is good. HA is good and the claim is in HA, that means you support the claim. And then you can make a conclusion to support the claim. Let's take another example. If I reject HO here, guys, if I can show you, we end up, just through some techniques rejecting HO. What can you say about the claim, guys? Remember, the claim is in HO. Can someone say something here? HO is bad. What does it mean for the claim? The claim is bad. That's right. That means you reject the claim. Because you rejected HO and the claim happened to be in HO, then you reject the claim. Let me just go back. One more fold here. Let's see if a student can answer right here. This is something we did already. Okay. Let's say, guys, we were doing this problem. And after I show you the other steps, we end up rejecting HO. What can you conclude about our claim? Remember, our claim is in HA, it's not in HO. Let me see what. Then the claim is good. Very good, guys. Yeah, we support the claim. Let me now show you another scenario. What about if we cannot reject HO? What would you say about the claim here in this question, number 5? We cannot reject HO. We say we can't reject HO. We fail to reject HO. Okay. Any comments? Yeah, that means that we cannot support the claim. Yeah. Not reject the claim. We say we don't support the claim. That is correct. So if you guys cannot reject HO, that means HO is not bad. That means your claim cannot be supported. So here's the conclusion, guys. If your claim is in HA, in order to support your claim, you must reject HO, but it's not up to you to reject HO or not reject HO. It's the data that's given to you will tell you whether to reject HO or fail to reject HO. What we're gonna do, we're gonna find a number, it's called the p-value. It's a probability. I'm gonna show you a nice fun video to watch. We find this number, the p-value, and I already explained to you the significance level alpha. Right here. We compare this p-value with alpha. This number that you can come up with, if it turns out to be less than alpha, you end up rejecting HO. If this number turns out to be more than alpha, you end up failing to reject HO. And what I'm gonna do, I'm gonna show you a video, just bear with me, and then we'll end the discussion for today. So please watch this video. It's a very important video just on the p-value and see why the p-value is important. So let me just try to get the video and show you this video. One second. Trying to get the document. Okay, chapter 7. Okay. Understanding the p-value.
Do you and your team need to work remotely?
And let me just share the screen with you guys. Okay, let's watch this video. I'm gonna pause and explain things as we do the video.
So you can continue.
Understanding the p-value. One of the most important concepts in statistics is the meaning of the p-value. Whenever we use Excel or other computer packages to analyze data.
Before I continue, guys, I need to ask you. I need to ask if you hear the voice, the audio. If you're hearing, just the audio here. Okay, good.
null hypothesis is true. We will now go through this step by step with an example. Helen sells chocolati's. Recently, she has received complaints that the chocolati's have fewer peanuts in them than they are supposed to. The packet says that each 200-gram packet of chocolati's contains 70 grams of peanuts or more. Helen can't open up all the packets to check, as then she wouldn't be able to sell any. So she decides to use a statistical test concepts and
So you guys, can you hear me now? Good. Okay, let's take care of. So I'm going to show you a video, and I will end the lesson after this about the p-value. It's a situation, a claim situation, how the p-value is used in statistics. So please watch this video.
And in the p-value. One of the most important concepts in statistics is the meaning of the p-value. Whenever we use Excel or other computer packages to analyze data, one of the key outputs is the p-value, or sig. In formal terms, the p-value is the probability that, if the null hypothesis were true, sampling variation would produce an estimate that is further away from the hypothesized value than our data estimate. In less formal terms, the p-value tells us how likely it is to get a result like this if the null hypothesis is true. We will now go through this step by step with an example. Helen sells chocolati's. Recently, she has received complaints that the chocolati's have fewer peanuts in them than they are supposed to. The packet says that each 200-gram packet of chocolati's contains 70 grams of peanuts or more. Helen can't open up all the packets to check, as then she wouldn't be able to sell any. So she decides to use a statistical test on a sample of the packets. The null hypothesis, often called H0, is the thing we are trying to provide evidence against. For Helen, the null hypothesis is that the chocolati's are as they should be. The mean or average weight of peanuts in the packet is 70 grams.
The alternative, guys, we call it HA in our book, and some other books they call it H1. It's the same thing.
Hypothesis, called H1 or HA, is what we're trying to prove. The customers have complained that the weight of peanuts is less than what it should be. So the alternative hypothesis is that the average weight of peanuts is less than 70 grams. Helen decides to use a significance level of 0.05. If the p-value is lower...
See, guys, I was telling you, just about the significance level. She's using 5%. She's going to find what they call a p-value. If her p-value is less than 5%, she will reject HO. If it's not less, she cannot reject HO.
Within this, she will reject the null hypothesis. Having decided on her hypotheses and on the significance level, Helen takes a random sample of 20 packets of chocolati's from her current stock of 400 packets. She melts down the chocolati's and weighs the peanuts from each packet. If all of the values were lower than 70 grams, with a mean of 30 grams for instance, it would be quite obvious that the bars did not have the required number of peanuts. It is very unlikely that you will get 20 packets with a mean of 30 grams if the overall mean of all the packets in the population is 70 grams. Conversely, if all the values of the 20 packets are much higher than 70 grams, it would be obvious that there were enough peanuts and that there was nothing to complain about. However, in this case, the 20 packets contain the following weights of peanuts, and the mean is 68.7 grams.
So what she did, she took 20 packets, she figured out, she cleaned them up, just of the chocolate. She figured out, the weight, just of the nuts in each one. And this is what she got for the 20. And then she figured out what X bar was. X bar was 68.7 grams, which is slightly less than the claimed 70 grams.
This caused Helen to ask herself, does this provide enough evidence that the bars are short of peanuts, or could this result just be from luck? She asked her brother to use Excel to find the p-value for this data, comparing with a mean of 70 grams. The p-value is 0.18. Judging from the data that we have.
So the p-value, guys, is 0.18, and the level of significance is 5%. Do you guys agree with me that the p-value is more than 5%? Did you say it is more? Yes. So that means if it is more than alpha, you cannot reject HO. So watch and hear her saying that.
There is an 18% chance of getting a mean as low as this or lower if there is nothing wrong with the bars. That is, if the null hypothesis is true and the mean weight of nuts is 70 grams or more. This p-value of 0.18 does not provide enough evidence to reject the null hypothesis.
So you cannot reject HO because the p-value is more than alpha, which is the 5%. Okay, let's continue.
In this case, Helen does not have evidence to say that the bars are short of peanuts. This is a relief. The smaller the p-value is, the less likely it is that the result we got was simply a result of luck. If the p-value had turned out to be very small, we then would say that the result was significantly different from 70 grams. In general, we start by saying that the null hypothesis is true. We take a sample and get a statistic. We work out how likely it is to get a statistic like this if the null hypothesis is true. This is the p-value. If the p-value is really, really small, then our original idea must have been wrong, so we reject the null hypothesis. P is low, null must go.
Did you hear that, guys? If P is low, null must go. Usually a small p-value, you reject HO. Not a small p-value, you don't reject HO.
P-value indicates a significant result. The smaller the p-value is, the more evidence we have that the null hypothesis is probably
false.
wrong.
Yeah.
If the p-value is large, then our original idea is probably correct. We do not reject the null hypothesis. This is called a non-significant result. The p-value tells us whether we have evidence from the sample that there is an effect in the population. A p-value less than 0.05 means that we have evidence of an effect. A p-value of more than 0.05 means that there is no evidence of an effect. Sometimes a significance level different from 0.05 is used, but 0.05 is the most common one. Disclaimer: this video uses plain language to get difficult ideas across. Some terminology might be viewed as incorrect by a rigorous statistician.
All right, guys. So let me just close the video. There we go. Okay, can you guys still hear me now? Okay, good. So I'm not going to bombard you with more stuff. What I'd like you to focus now on how to state the null and the alternative hypothesis. I'm going to send you a handout today that you can do some practice with the null and the alternative hypothesis and identify the claim. Tomorrow, I'm going to make myself available for students who would like, just to have questions. It will be in real time, probably around 10 or 11. I will survey you on this. I'll give you different times, and then you guys tell me what would be a good time. But that will be optional. But if you have any questions, please feel free, because you won't be able to come and see me during office hours. So we're going to do it online. And then on Wednesday, we'll meet again at the same time. I recorded this session, and I think it is still recording. Yeah, it is still recording. And I will make, just a link available today. It takes hours, for the video to be available. I have to render the video. It's a lot of work. So it's not as simple as saving the video and uploading it, just to YouTube. It doesn't work like that. But I will make this available. I do apologize for the glitches, guys. I told you they're going to be glitches. I cannot control them sometimes, but we'll try, just to do better. If you guys have any comments about, you think it will work, this way, please let me know. If you have some other suggestions, please also let me know. But I'll try my very best to do that. Yeah, sure. We'll work together, guys, just to get through this. And I'm hoping the next time some of the glitches, just would not show up. But sometimes I don't have a control of it because I'm using a third-party software, so I don't have a control of what's happening in there. All right, guys. So you'll hear from me again, and I'm going to send you the stuff, send you the link to the recording. Please check your email on a daily basis. And the Hotmail, I will be sending you stuff on the Hotmail, and I will make, Chapter 7, Section 1 available online. You only can do the null and the alternative hypothesis now, so you don't have to do, you can go beyond that. There are videos also under Section 7.1. You can watch the videos in addition to what we're doing in class.
that should be very helpful as well. So please check your email. I will send you some information today. And we will meet again tomorrow. I will make some time available, guys. I will be available, and we'll do video and audio this time. I won't mute you, I promise. All right? Oh, it's the chapter 7 is going to be there for a couple weeks. Okay, take care, guys. Yeah, tomorrow for optional hours. Yeah, yes, Rayan. And Wednesday we'll have a class again. At the same time, you use the same link. You don't have to choose any other link. I will resend you the link, no worry. And I'm going to send you the guided notebook right now.